Hi everyone, welcome to the walkthrough of paper 3H from November 2020 GCSE Maths from Edexcel. So in this paper, I will be looking at each question and giving you a bit more detail to what is available in the mark scheme. So we will be looking at different methods to complete each question. Okay, question number 1 is a simplify n cubed times by n to the power of 5. So when we're multiplying indices of the same base, and we can simply add the powers together. So 3 plus 5, it is n to the power of 8. Right, part B, it says c cubed and d to the power of 4 divided by c squared divided by d to the power of 1. Because if there's no power, we can make that to 1. So again, when we're dividing indices of the same base, we can simply take away the powers. So c, 3 take away 2, and d is 4 take away 1, and c, and times by d to the power of 3, or d cubed. Okay, part C, solving this inequality. So again, multiplying both sides by 2 first. So that is going to leave us with 14 on this side. And x is bigger than 14 divided by 5. Okay, that's question number 1. Okay, question 2, it says Andy cycles a distance of 30 kilometers at an average speed of 24 kilometers per hour. And then he runs a distance of 12 kilometers at an average speed of 8 kilometers per hour, and work out the total time and it takes, and give your answers in hours and minutes. Okay, the formula that you need here is speed equals distance over time. Now, if I times both sides by time, we have speed times by time equals a distance, and then time equals, now it's multiplying here, so we're going to divide both sides by speed, and is distance over speed. So looking at part 1 of the journey where he cycled, the time for that, if we substitute the numbers into this formula, that's 30 kilometers over 24 kilometers per hour. That is 1.25. Now this is 1 hour, and 0.25 is 1/4 of an hour, which is 15 minutes. Okay, and then part 2 of the question, when he runs. So again, we do the same thing. Distance is 12 and the speed is 8, which is 1.5 hours. So again, we got 1 full hour, and 0.5 is half an hour, which is 30 minutes. Okay, so altogether, so we got 1 hour, 2 hour, 15 minutes, and 30 minutes. So it's 2 hours and 45 minutes. Okay, and number 3, a number m is rounded to 1 decimal place, and the result is 9.4, and complete the error interval for m. So that means any numbers which was bigger than 9.35 would have been rounded to 9.4. So any numbers which were, so I'm just going to write this on this side here, bigger than or equal to, and any numbers which are less than 9.45 would have been rounded again to 9.4. So the error interval 9.35 on this side and 9.45 on this side here. Okay, so that's question number 3. Okay, question number 4 says Macy knows that she needs 3 kilograms of grass seed to make a rectangular lawn 5 meters by 9 meters. And the grass seed is sold in 2 kilogram boxes, and Macy wants to make a rectangular lawn 10 meters by 14 meters. and she has 5 boxes of grass seeds. Has Macy got enough grass seeds to make a lawn of 10 meters by 14 meters? And you must show all your working out. Okay, like first I'm going to work out the area of the lawn that she can cover using 3 kilograms of grass seed. So that is 45 meters squared, and 3 kilograms of grass seeds cover that. Then the lawn that she wants to make is 10 meters times by 14 meters, and that's 140 meters squared. Okay, so if I divide this area by 45, I get 3.111 recurring. And we know that 45 meters squared is covered by 3 kilograms. So 3.111 times by 3 should give us how much kilogram of grass seed we need, which is 333. And if the grass seed is sold in 2 kilogram boxes and she has 5 boxes, 5 times by 2 is 10 kilograms altogether. So the calculation shows this is how much we need and this is how much we have. So that means she has enough grass seed. Okay, so just write down your closing statement for this question. Okay, part B of this question says, Macy opens the 5 boxes of grass seeds. She finds 4 of the boxes contain 2 kilograms of grass seed. The other box contains 1 kilogram of grass seed. Does this affect whether Macy has enough grass seed to make a lawn? And give a reason for your answer. Okay, so 4 boxes contains 2 kilograms, so that's 8 kilograms, and plus 1 more, that's 9 kilograms of grass seed that she already has. Now, if you go back to question or part 1 of this question, she needed 9.3 recurring. So we need 9.33. So that means, yes, it will affect her answer. She has less grass seed available now. Okay, so again, write your closing statement stating that fact. Okay, question 5. It says Amanda has 2 fair 3-sided spinners. Now, Amanda spins each spinner once, complete the probability tree diagram. Now, for the spinner A, it says lands on 2. Now, there is only 1 2 here out of 3, so that's 1 over 3, and does not land on a 2. Well, there are 2 numbers that are not 2, so 2 out of 3. And the spinner B lands on 2. Again, we have just got one option there. 2 over, just get rid of that. It's 1/3. And same thing over here, does not land on 2, 2/3, and 1/3, and 2/3. Okay, part B of the question says, work out the probability that spinner A lands on 2 and spinner B does not land on 2. So spinner A is over here, it lands on a 2, and spinner B does not land on a 2. So we're looking at this part of the probability tree diagram. So 1/3 times by 2/3, and we have 2 over 9. Okay, so that is the probability that the spinner A lands on a 2 and spinner B does not land on a 2. Okay, question number 6, nice and easy for 1 mark. It says use these graphs to solve the simultaneous equations. 5x take away 9y equals minus 46 and y equals minus 2x. Now the solutions are where the lines cross each other, and it's the intersection point. So if you read the x value, which is -2, so that's -2. If you read the y value, that is 4. So that is the answer for this question. Okay, part B, it gives us another graph. So this time of a quadratic equation, x squared minus 4x plus 2 equals 0. And it says use this graph to find the estimates of the solution of the quadratic equation. So this time, we need to look at where the graph crosses the x-axis. So there would be one point here and the other point is over here. Now, if you look at the scale, we've got 10 squares representing 1 unit. So this graph over here, this point over here, looks like it's crossing from 0.6. So one solution is x equals 0.6. The other one is over here, which is 3.4. So x equals 3.4. Again, nice and easy question to complete. Okay, question number 7. It says there are a total of 45 boys and girls in a choir. And the mean age of 18 boys is 16.2 years and the mean age of 27 girls is 16.7 years. And it says calculate the mean age of all 45 boys and girls. Okay, again, a fairly standard question on mean, and we can find the total age of the boys by doing 18 times by 16.2, and that is 291.6. And then we can find the total age of the girls, that's 27 times by 16.7, which is 450.9. Now, if we add these two values together, 291.6 plus 450.9, that comes to 742.5. Now, since there are altogether 45 boys and girls, so 742.5 divided by 45, that gives us 16.5 years. Okay, so that's 3 marks and you have shown all your working out. Okay, question number 8. It says there are some counters in a bag. The counters are blue, green, red or yellow. And the table shows the probabilities that a counter taken at random from the bag will be blue or green. So they already given us 2 piece of information for blue and green. And the probability that a counter at random from the bag will be red is 5 times the probability that the counter will be yellow. So if yellow is X, that means red will be 5 times that. That would be 5x. And there are 300 counters in a bag. Work out the number of yellow counters in the bag. Okay, so the probabilities add up to 1. So we can write down 5x plus another x plus 0.32 plus 0.2, and it all equals 1. Okay, so then we got 6x plus 0.52 equals a 1, and 6x equals 1. Take away 0.52, and 6x equals 0.48. Okay, so x equals, dividing by 6 on both sides, 0.08. Okay, so that's the value for x. And now we can figure out how many yellow counters are there. Well, yellow is x, which we just worked out. So 0.08 times by 300. And there are 24 yellow counters. Okay. Okay, question number 9 is 5-mark question, and it says the diagram shows a prism. The cross section of the prism has exactly 1 line of symmetry, and work out the volume of the prism and give your answer to 3 significant figures. Now, to work out the volume of a prism, we can use a formula that is volume of prism equals the cross-sectional area times by the length. Okay, now the cross-section area is this area at the front here, all of this, and then we will simply times that by 20, and that will give us the volume. Okay, now to find the area of the cross section, well, one part of that is quite straightforward, because we have a rectangle 10 by 12 at the front. So we can start off by doing 12 centimeters by 10 centimeters, which is 120 centimeters squared. Now we need to work out the area of this triangle here. Now if I just take out this triangle out and just have a look at this separately, and we know that if this is 10, the base of that triangle is also going to be 10, and we got this as 40 degrees. Now since it says it has a one line of symmetry, so that means this shape is symmetrical, so therefore this is an isosceles triangle, so we got another 40 degrees angle here. And to find the area of a triangle, we need the vertical height. So the vertical height, if we have that, we can simply times by 10 and halve it. But we haven't been given that side. So what we're going to use is SOHCAHTOA to figure that one out. Because we given a triangle, we have an angle in there. Now the one side at the bottom here, if it's symmetrical, so that is going to be half, which is 5 centimeters. So now we need to work out the height, which is the opposite, and the side which is given is adjacent. So remember, the other side is the hypotenuse, this long side here. So we need a formula that links together opposite and adjacent, which is TOA. And so if we write this down, tan of x, or tan of the angle, equals opposite over adjacent. And we need the opposite because we're looking for the height of that. So if I rearrange this formula, it is going to be tan of x times by adjacent equals opposite. So I'm just going to put these values in here. So the opposite equals tan of 40 times by adjacent, which is 5 centimeters. Okay, that equals 4.195. Now leave the rest of the numbers in the calculator. So that is the height of that triangle. So to find the area of the triangle, we need to do half times by 4.195 and times by the base of that triangle, which was 10, and work this out. Okay, that is 20.975 centimeters squared. So the area of the triangle is 20.975, and the area of the rectangle that we worked out earlier. So add these two numbers together, 120 plus 20.975. That equals 140.975. So that's the cross-sectional area. So now go back to our formula at the top there. To work out the volume, okay, so the volume is going to equal 140.975 times by the length of the shape, which over here was 20 centimeters. So 20 centimeters. And that should give us 282023 significant figures. Okay, so that is the answer for this question. Okay, question number 10 says, a person's heart beats approximately 10 to the power of 5 times each day, and a person lives for approximately 81 years. And work out an estimate for the number of times a person's heart beats in their lifetime, and give your answer in a standard form and two significant figures. Okay, we can estimate this. There are 365 days in a year, so we can do 10 to the power of 5, that's per day, and times by 365 days in a year, and a human being approximately lives for 81 years. And if you multiply this out, we got something like 2.9565 times by 10 to the power of 9. Now, since they want the answer in a standard form and two significant figures, so focus on this part here. That's the first significant figure, and that's the next one. Look at the third number, that is 5 or bigger. So we need to add 1 to this, but that will make it a 10. So, and then you need to carry that 1 over, and that should make 3.0 times by 10 to the power of 9. Okay, part B says 2 times 10 to the power of 12 red blood cells have a total mass of 90 grams. And work out the average mass of one red blood cell and give your answer in a standard form. So if there are 90 grams altogether, and there were 2 times 10 to the power of 12 blood cells, and that is going to be a very small number. And if you put that in on the calculator, you should get something like 4.5 times 10 to the power of minus 11. So a very, very small number, but that is the answer for this question. Okay, question 11, it says the diagram shows a triangle P on the grid, and it says triangle P is rotated 180 degrees about 0, 0, and to give a triangle Q, and then it is translated, and the triangle Q is translated by 5 and -2 to give triangle R, and describe fully the single transformation that maps P onto triangle R. Okay, so we're going to look at this in stages. Let's have a look at triangle P first, and it is rotated by 180 degrees from 0, 0. Okay, now you can use a tracing paper, trace the shape out, and turn it around by 180 degrees. Okay, so this is where triangle Q is, and then it is translated by a vector 5 and -2. Now +5, that means it's gone to the right, and -2 means it's gone down. So let's count that here. So 1, 2, 3, 4, 5, 1, 2. So the new point is here. So let's draw the new shape out, and we're going to call this R. Okay, and it says describe fully a single transformation that maps P onto R. Now, if you look at these two shapes, I'm just going to get rid of this. So P and R, R is a rotation of P, and by 180 degrees, and we have to find a point somewhere where they have been rotated from, or the center of rotation. Now again, you can use a tracing paper to trace out where R is, and then or where P is, and then try to rotate from different points until you find that point. Now, when I did that, it was at 2.5 and -1. And you can check this, because if you look here, if you look at this corner, this is 1, 2, 3, and 1.5 this way. And if you look at this corner, it's 1, 2, 3, and 1.5 across. So they're the same distance from that point there. So the answer to this question is rotation, okay, by 180 degrees from the center of rotation is 2.5 and -1. Okay. Okay, part B is under the transformation that maps P onto R, the point A is invariant. Now, invariant point is which do not move. So it stays at the same place. So sorry, do not move. Now, again, bit of unusual question, because normally they ask for the point on the shape, which is invariant. Now, at this point, if you look at P and if you look at R, all the points have moved. The only point which has not moved is under the transformation is the center of rotation itself. So that must be the answer, that the only point which has not moved is 2.5 and minus 1. Okay, that's the answer for this question. Okay, question number 12 is given us two algebraic fractions, and it says write as a single fraction in its simplest form. Okay, so I'm going to start with a lowest common multiple, which is going to be x plus 2 and x minus 4. Okay, and then we can look at the denominator here. X plus 2 times by x minus 4 makes the denominator. So we're going to multiply this x with x minus 4. And then the next one, again, x minus 4 times by x plus 2 makes the denominator. So that has to be multiplied by 2x. So x plus 2. Okay, so let's just extend that line a little bit more. And I'll simply just simplify this by multiplying out the brackets. So we got x squared minus 4x, and then plus 2x times by x is 2x squared, and then plus 2x times by 2 is 4x. And then again at the bottom, nothing changes here. We can just leave that in a bracket and x minus 4. Okay, now simplify the top or the numerator. We have x squared and plus 2x squared. So that's 3x squared, and then minus 4x and plus 4x is a 0, it's going to cancel out. And then that's our numerator, and the denominator is going to be same, x plus 2 and x minus 4. Just have a check if you can't cancel anything down. I think that's pretty much it, and that is the answer for this question. Okay, so moving on to part B, and it says expand and simplify, and we're given 3 binomials, and you can multiply any of these brackets together and then multiply the answer by the third one. So I'm just going to focus on these two here first, and x times by 2x is 2x squared, and x times by plus 3 is plus 3x, and minus 3 times by 2x minus 6x, and then minus 9. And then simplifying this, we have 2x squared minus 3x minus 9. So I'm going to put this in a bracket and then multiply by the third bracket, which we haven't used so far. Just going to write this on the other side here. And again, starting with the first one, 4x times by 2x squared, that is 8x cubed. And 4x times by minus 3x, that's minus 12x squared. And then 4x times by minus 9, minus 36x. And then 5 times by 2x squared, plus 10x squared. And 5 times by minus 3x, minus 15x, and the last bit here, 5 times by minus 9, minus 45. So now just simplify these or collect like terms. So the only term with cube is 8x cubes, and then minus 12x squared plus 10x squared, that's minus 2x squared. And then we have minus 36x and minus 15, that's minus 51x, and then we have minus 45. Okay, so a bit of working out, but eventually it will reduce to 4 terms. Okay, question number 13 is inequalities and identifying the region that satisfies all these inequalities. Now the first one it says is x is bigger than or equal to 0, and then we got x is less than or equal to 2, and y is less than or equal to x plus 3, and 2x plus 3y is bigger than or equal to 6. So we have to draw all these lines on the graph and then identify the region which meets all these conditions. Well, the first two is fairly straightforward. It says x has to be bigger than or equal to 0. So we know that x is a 0 on this line, basically the y-axis. So we can draw in our line on here, which is x equals a 0 line. Now anything on this side would be bigger than, so that is region of interest so far to us. Now the next line it says x has to be less than or equal to 2. So again, draw out your line because x is anywhere on this line, which is 2. So draw this line out and we get this line here, and this line is x equals a 2 line. So x has to be less than a 2. So that means again, so the region enclosed so far by these 2 lines is the region that we are interested in. Now moving on to the third line here, which is y is less than or equal to x plus 3. So again, you can have a table of values, or you can have a couple of coordinates that you can work out and plot that line. So if I write this down here, y equals x plus 3. Now I'm just going to work out 2 coordinates. When x equals a 0, what is y equal? So y equals 0 plus 3. So y equals a 3. So that's our one set of coordinates. Now, when y equals a 0, what is x equal now? So if I put a 0 here, we got x plus 3. So that means taking away 3 from both sides, x will equal, so x will equal minus 3. So x equals a minus 3. So plot these coordinates in. So when x is 0, y is a 3. So x is 0, y is a 3. And then when y is a 0, x is minus 3. So another point will be here. So again, just draw your line out through these points. As I said, like 2 points are good enough to draw a straight line through there. So that is our line for y equals x plus 3. So, but y has to be less than or equal to x plus 3. Now, how do we decide that? So is it going to be above the line, or is it going to be below that line that satisfies that region? So if I select a coordinate here, the x is 1 and y is 3. So x is 1 and y equals a 3. Now, if I put this in to this equation here, if x is 1, y is a 3, is it true that y is less than or equal to x plus 3. So if x is 1, and so that will make 4. So yeah, 4 is bigger than or equal to 3. So we know so far we're looking at this region, not the one above that. So I'm just going to rub this out. So we're not interested in this region so far at the top. So everything at the bottom so far makes sense. Now the fourth one now, it says 2x plus 3y. I'm going to make that into equal as 6. So again, I'm going to work out two coordinates when x equals a 0. So when x equals a 0, so 2 times by 0 is a 0. 0 plus 3y equals a 6. So y must equal 6 divided by 3. So y is a 2. So when x is a 0, y is a 2. So that's one of the coordinates I can work out. The other one is when y equals a 0. So if I put this back into this equation, so 2x plus a 0, because 3 times by 0 is a 0, equals a 6. And we got 2x equals a 6 and x equals a 3. So we have another set of coordinates. X is a 3 and y is a 0. Okay, so if I plot these coordinates, 0 and 2 is over here, and 3 and a 0 is over here, and just draw a line through these coordinates, and let's see what we have. So again, extend the line as much as you can here. So that's a line for 2x plus 3y equals a 6. But the inequality region that we're looking for, that 2x plus 3y has to be bigger than or equal to 6. Okay, so I'm just going to pick one coordinate from here. Let's see if that works. Okay, so I'm just going to pick this coordinate again. X is 1 and y is a 2. Now I'm going to substitute this into this inequality, and 2x, 2 times by 1 is 2, and then 3y, 3 times by 2 is 6. Is it bigger than or equal to 6? Yes, it is, because 8 is bigger than or equal to 6 for sure. So that means the region that we are looking for, I'm just going to get rid of all this, is in the middle over here. So this is the region that satisfies all these inequalities, and you can actually write this down, R in the middle. Okay, part B, they have given you a graph with 3 lines on there and a shaded region S, and it says Jeffrey says that the point with coordinates 2, 4 does not satisfy all inequalities because it does not lie in the shaded region. Now, if you look at 2, 4, 2 and a 4 is over here, okay? Now, you can look at each inequality separately. So we know, well, if you look at the diagram, this is y equals 4x line, and this looks like y equals half x, and the final line which is given here is x plus y is less than or equal to 6, or we can say equal to 6 line here. Now, if you look at this, if I substitute 2 and a 4 into all of these inequalities, for example, in here, if let's just write this down, 2 and a 4. So y coordinate is 4, and if you put x in as a 2, 2 times by 4 is 8. So it definitely satisfies that inequality because 8 is bigger than or equal to 4. Now, if you look here, so again, substitute that into there, we got 4. Is it bigger than or equal to half x? Well, half times by 2, that is 1. So 4 is definitely bigger than or equal to 1. So it satisfies that inequality as well. And the last one, x plus y Okay, so if we add the coordinates together, 2 plus 4, is it bigger than or equal? Is 6 bigger than or equal to 6? Yeah, it does. So it also satisfies, because we've got 6 on this side here and we've got 6 here. So it definitely satisfies all three inequalities. So is Jeff, I'm just going to write Jeff and give him a nickname, is incorrect. Okay, and because of the reasons that I have given you above, okay, the working out. Okay, question number 14 is on circle theorems, and it says points B, D, E, F lie on a circle. ABC is a tangent to the circle at point B, which is here, and find the size of the angle ABD. So ABD is this angle over here, and it says you must give a reason for each stage of your working. Okay, so looking at the diagram, we have a cyclic quadrilateral, a four-sided shape in a circle, and the opposite angles add up to 180 degrees. Okay, so write your reason, and working out 180, take away 100, and that's 80 degrees. So the angle over here, this angle is 80 degrees. Okay, so now we have two angles in this triangle BDF, and we can work out this angle here by doing 180, take away 80 and take away 40. Okay, so that is 120. So that'd be 180 take away 120, so 60 degrees. So this angle here is 60 degrees. Okay, so the reason for that is angles in a triangle add up to 180 degrees. And now the final bit here, this angle 60 or angle BFD is alternate segment theorem, because we've got a tangent here and we have this triangle, and the alternate segment theorem says that this angle must equal angle ABD. So you can write this down, ABD equals 60 degrees because of alternate segment theorem. Okay, so this is the answer and all your reasons for this question. Okay, question number 15. Prove algebraically that 0.73 with only 3 is recurring can be written as 11 over 15. So you have something to work with, and if you get the answer as 11 over 15, so you know you have done this question correct. So there's a standard way of doing this question. I'm just going to put x as 0.733 and so on recurring. Now we can do 10x or we can do 100x. If you did 10x, for example, and this would be 7.333 and so on. I guess you can work from here, but I'm just going to go one step ahead. I'm going to do 100x. So 100x means times this by 100. So that is 73.333 and so on. Okay. Now, if you look here, if I did 100x, take away 10x. So I'm just going to write down 10x again underneath there, which is 7.333 and so on. If I take these two values away, all these three recurrings will cancel each other out because everything will be minusing with the other one. So 100x take away 10x is 90x. And then we have 73 take away 7. That will be 66. And if you make x the subject, so divide both sides by 90, we've got 66 over 90. And now if you divide by both sides by 6 and divide by 6, we get 11 over 15. Okay, or you could have just done 90 divided by 15 in here and then divide by 11. Just use whatever information is given to make it simpler for you. Okay, so 11 over 15. Okay, question number 16, it says here's a speed time graph for a car, and work out the estimate for the distance that car traveled in the first 30 seconds. Now, if you notice here, most of the time you will get distance time graphs, but this is speed and time graph. So the area under the graph, okay, gives us the distance. So area under the graph is distance. Now, normally they will tell us how many different calculations they want us to do, or how many different strips under that graph we need, but it doesn't tell us anything. So we are going to estimate the area in the first 30 seconds. Now, if you look at the scale on the horizontal axis, 30 seconds is here. So if I was to find the area under the graph, I'm just going to draw out a line here. Now, this side of the shape now in the first 30 seconds looks like a triangle. It's not a perfect triangle. Okay, the perfect triangle would be like something like this, okay? But since we're only estimating, I'm just going to take that as a triangle. And to find the area of the triangle, we can have a height and the base, and basically half times by base times by height. Now, if you look at the height of this triangle, which is 9, so estimating, which is 9, and we got 30 on this side, so the area is half times by base, which is 30, and times by 9. So that is half of 30 is 15, and 15 times by 9 is 135 meters. Okay, part B says, is your answer to part A underestimate or overestimate of the actual distance the car travelled in the first 30 seconds? Give a reason for your answer. Now, for this one, if you look at the diagram, when I drew the triangle in and we found the area of the triangle, so what it left was we have not taken into account that the area left over here outside this perfect triangle. So that means our answer is an underestimate, because we have not taken into account the whole area, because it's very difficult to do because we're only estimating and we just draw in the triangle. So it's an underestimate. Okay, so write a reason in. It's underestimate as the area between the line and the curve not included in the answer. So the area that I just shown you. Okay, part C. Okay, so it says Julian used the graph to answer this question. Work out the estimate for the acceleration of the car at the time 60 seconds. So here is Julian's working out. Acceleration is speed divided by time, 13 divided by 60, and Julian got an answer at 0.216 with 6 recurring. Julian's method does not give a good estimate for the acceleration at the time 60. Explain why. Okay, for this part of the question, now what gives us acceleration, okay, on this graph? So going back to the graph, and if you look at the first 60 seconds, and 60 seconds is roughly at the top here, okay? Now, to find the acceleration, you basically need to find the gradient at that point. So you will need to draw a tangent like this, following the shape of the curve at that point. So you need to have a tangent and then find the gradient of this tangent to find the acceleration. So Julian has not done that. Okay, so a reason would be Julian has not drawn a tangent to the curve at 60 seconds and did not work out the gradient at time 60 seconds. Okay. Okay, question number 17, it says the histogram gives information about the distances 80 competitors jumped in a long jump competition. And it says calculate an estimate for the mean distance. So we already have a histogram drawn for us, and we want to go backwards and look at how many people were represented in each of these sections. So the formula that you would normally use in histograms is frequency density equals frequency divided by class width. And the class width is basically the groups which are at the bottom on the distance side. So I'm just going to create a table here. So we have distance and the frequency. And so let's just make a table, and then we can start looking at the graph here. Now in the first section, this group here is between 6.4 and 7.2. So 6.4 to 7.2. And the frequency you can work out, well, we got frequency density of 10. Now if you look at this formula, the frequency would equal frequency density times by class width. So it's the area of the bar that will give us the frequency. So if you look at 7.2 and 6.4, so we can do 7.2 take away 6.4, okay, that is 0.8. And then 0.8 times by 10, okay, that is 8. So the first, in the first bar, there are 8 people represented there. In the next group is between 7.2 to 7.6, and the frequency density is 50 over here. So if you did 7.6 take away 7.2, that is 0.4, and then 0.4 times by 50, and that is 20. So in the next group there are 20 people represented. Okay, the group after that is 7.6 to 8.0. So 8.0 take away 7.6, and we have 0.4, and then 0.4 times by, and the frequency density is 100, so that is 40. So there are 40 people represented here. And then the final bar is between 8 and 8.2 over here. It's in the middle of 8 and 8.4. So 0.2 times by, and the frequency density is 60. So that is 12 people on this here. So let's write this down. So 8.0 to 8.2, and we have 12 people represented here. Now, if you look at the total people here, it should add up to 80, okay? So that's 60 in the middle, and then 8 and 12 makes 20. So that's 80 people altogether. So that's a good sign that we have done our calculation correctly. Okay, so now to find the mean. So when the data is given in a group, we look at the midpoint of each group there. Now the first group, the midpoint there, you can do 7.2 plus 6.4 and divide by 2. So the midpoint is 6.8 for the first one. And we have times by 8. And the next midpoint between 7.2 and 7.6 is 7.4. And that will be times by 20. And the next midpoint is 7.8 times by 40. And then 8.1 times by 12 and work out each of these values here. Okay, so if you work this out, these are the values you're going to get. And then to estimate the mean distance, we want the total distance covered. Now, if you add all of them together, we get 611.6, and the mean, the estimate of the mean would be 611.6 divided by 80 altogether, because there are 80 competitors. And if you work that out on the calculator, that is 7.645. Okay, so that is the mean distance from this question. Okay. Okay, question 18, it says the diagram shows a cube and A to H is 11.3 centimeter to the nearest millimeter. So when you see this word to the nearest millimeter, so we know that this question is about bounds. And it says calculate the lower bound of the length of an edge of the cube. Now, starting with 11.3 to the nearest millimeter, so the lower bound of this length would be 11.25 and the upper bound would be 11.35. So we will be using lower bound in this question because we calculate the lower bound of the length of an edge of the cube. Okay, now we don't have any lengths of a cube, so I'm going to call this x, and x here. So basically all the lengths would be x since it's a cube. Now they've given us a distance A to H. So if I just draw a line from A to H, okay, so that is given as 11.25 to the nearest millimeter. Now we need to go back here and find the length of an edge of the cube. Now, how would they have found A to H? Now, to find A to H, we need to find the distance between F to H and then A to F, because you can square them using Pythagoras theorem to find what A to H is. So I'm just going to draw out a triangle here and label this as, so this is H and this is A and this is F. So this side is given as 11.25. Now A to F is going to be X because that's the height of the cube. And F to H is a distance that we need to find. Now, how to find F to H? So F to H would have been found by using a Pythagoras theorem. So again, I'm just going to draw out another triangle here. So if this was F and H, and this is E. So E to H is X, and this is X. So F to H is if you square the both sides, F to E and E to H, and add them together, so we got X squared using Pythagoras theorem plus X squared, and that is 2x squared. I'm just going to leave this here. Okay, so this is F to H. F to H would be the square root. Okay, so the square, remember when you find a missing side, the last thing you do square root of the missing side. So we got root 2x squared on this side. Okay, so now to find A to H, okay, so you can do x squared plus the square of this side. So that means just removing the square root if you're going to square that side. So that's plus 2x squared, and that equals 11.25 squared. Okay, so now we can collect the like terms together. So that is 3x squared equals 11.25 squared. That is 126.5625. So leave this in the calculator, and the next step you will do is you divide both sides by 3. So this number 126.5625 divided by 3, and then you would square root in the end the whole of this number to leave us with the x value. Okay, so this is what you are going to get on the calculator, 6.495 and few decimal places. And if you round this up to one decimal place, it is 6.5 centimeters. Okay, so that is the answer for this question. Okay, question 19, it says A, B, C, D, E, F is a regular hexagon. So all the sides are the same, with the side length of x. So we got x there, and all of these sides are x in the smaller hexagon. And this hexagon is enlarged from the center F by a scale factor of P. So they're given us a linear scale factor of the length, not the area, to give the hexagon F, G, H, I, J, K. So the bigger hexagon is an enlargement of the smaller hexagon. And it's to show that the area of the shaded region in the diagram is given by this expression. Okay, now that looks pretty scary question, but if you take one step at a time and have a real think about this, we can work in stages, and hopefully I can show you how we get to the answer in the end. Now, the few things to note here: when you find the area of the shaded region, okay, so shaded region is always the bigger area. So the bigger hexagon, the area of that, take away the smaller hexagon or the smaller area, and that will leave us with the shaded region. And also another thing to note here, a scale factor of P. So when you're given a scale factor and similar shape rules, the area always increases by the scale factor squared, because they're giving us a linear scale factor here. So two things to note before we start doing this question. Okay, so I'm going to start off by looking at the smaller hexagon. And if you look here, if I draw out a triangle here and a triangle here, and make it into two triangles and a rectangle, and I can find the area of both of these triangles and then the rectangle and add them together. Now, again, from our knowledge of the area of a triangle, which is not a right angle triangle, is half AB sine of C. Sine of C, that's the formula for the area of a non-right angle triangle. So we need to have the size of this angle F or AFE. Now, remember this formula, the sum of the interior angles, n take away 2 times by 180, and n is the number of sides, which are 6 in this case. So 6 take away 2 times by 180 is 720, and then divide this into 6. So divided by 6 is 120 degrees. So this angle here is 120 degrees. Now, if we put this information into this formula, so the area of one triangle is half times by x and times by sine of 120. Okay, now if you work out the sine of 120 on the calculator and leave your answer in a third form, okay, so we will get something like this: x times x is x squared, and the sine of 120 is √3/2. So this is the area of one triangle. Now, since the other triangle, which is over here and is exactly the same area, so you can double that and, or basically simply don't half this area, because you're only going to end up doubling it because there are two triangles. So the area of the both triangles, okay, so both triangles is x squared root 3 over 2. Okay, now the area of the rectangle. Now we know this is x, and we don't know the length of this side here, A to E. Now, if we were to draw out a triangle here, split it up into half, and if I take this triangle out, okay, and this angle would be 60, okay, and this side here is not given to us, okay, but this side is F to E, which is X. So I should be able to find the length of this side. Again, you can use SOHCAHTOA for this one here. So we're given the hypotenuse and we're looking at the opposite. So sine of x equals opposite over hypotenuse. And we're looking for the opposite. If you make opposite the subject here, so opposite going to equal sine of, so I'm just going to write this underneath here to have more room. So opposite equal, let's put this information in. We got sine of 60, okay, and times by x, that is the hypotenuse. And if you look at sine of 60 on the calculator, okay, which is also root 3 over 2, and then times by x. Okay, so that is this one side, so which is root 3 over 2 x. But then since, okay, the rectangle is double of that, the side length, so this is also going to be root 3 over 2x. And if we add them together, so we got root 3 over 2x plus root 3 over 2x. So this is two lots of root 3 over 2x. Okay, so if we were to simplify this, so that comes to the 2's, if I times that by 2, this 2 would cancel with that one. So we're left with root 3x. Okay, so the rectangle that we have, one side is x, the other one is root 3x. Now the area of this is x times by root 3x, so which is root 3x squared. Now, if we now put together the area of two triangles, which was over here, and the area of a rectangle, add them together, so the total area of the hexagon would be, I'm just going to write this down as root 3 over 2x squared plus root 3x squared, and add them together. And so again, I can make this into a fraction, root 3 over 1, and times this fraction by 2 to get the common denominator. So root 3 over 2 x squared plus 2 lots of root 3x squared over 2. So add them together, we get 2 here, and then we got root 3x squared at the top here, and we got root 3x squared, and we got 2 of them here, 1 of them here, so that's 3 root 3 x squared. Okay, so now, so that is the total area of the smaller hexagon. Now, the shaded area we can figure out by, so the area of the bigger hexagon would be, because we're given a scale factor of p, so that means p squared times by 3 root 3 over 2x squared would be the area of the bigger hexagon. Okay, if we take away the area of a smaller hexagon, which is 3 root 3 x squared over 2, that will leave us with the shaded part here. Okay, so this is what you have to do next. Okay, so if you have a look here, we have a common factor which I can take out and factorize this expression. So the common factor is 3 root 3 over 2 x squared, and take that out, and then we left with p squared on this side, and then minus, and we got the same thing on this side here, and that would be 1. Now, if you go back to the question over here, that looks very similar to what I have worked out at the bottom here. So you can write this in the same way, because it's exactly the same thing. So we can write down, if I just show everything on one screen here, we got 3 root 3 over 2, and we got p squared minus 1, and we can have x squared in the end. So you have shown them that is the shaded region of this. Okay, question number 20, 1 mark question. It says, here a list of 5 numbers. Find the lowest common multiple of these numbers. Okay, so the lowest common multiple is, well, this is the biggest number here. So all these numbers will multiply into this number here. So for 1 mark, it can't be that complicated question. So 98 to the power of 91. Okay, so question 21, it says 5c plus d equals c plus 4d. Find the ratio of c to d. So if we put everything together, so we'll have 5c minus a c equals, basically rearranging this equation. We got 4d, and take d away from both sides, minus a d. So we are left with 4c equals 3d. And then we know that 1c would equal 3/4 of a d. Okay, so this is the last part that you could understand. So 1c equals 3/4 of a d. So if d was, let's just say, a 4, c is 3/4 of that number, which is 3. So the answer, c to d in a ratio, would be 3 to 4. Okay, so there's no equal sign here. It's a ratio. Okay, part B is we have a quadratic equation, and it says find the ratio of x to y. So I would put everything equals 0. We got 6x squared minus 7xy plus, now it should be a minus because we're taking away 20y squared from both sides, equals 0. Now, if you factorize this, so very quickly, again, you need your factorization skills here. So we know that y squared, we'll have to have a y, and we got x squared, x and an x. And then find the numbers that multiply in 6 to make 6. We have 2 and a 3. So let's just put 2x over here, and we got 3x. And then to make 20, 4 and 5, just be careful which side each number goes. So you can do a bit of trial and improvement with the signs as well. And if you look here, the answer here, we got 5y, and we got 4y, and we got 2x and a 3x. Okay, so looking at this part of this question here, so we got 2x minus 5y equals 0, and 2x equals 5y, and x equals 5 over 2y. So x is 2.5 times the value of y. Okay, so x is 2.5 times the value of y. So if we got 5 on this side as x, and y would be a 2, because that would be times by 2.5. So x to y is 5 to 2. Now if you look at this question here, so that would be 3x equals minus 4y, and we don't want to really go into negatives, so the x would be 5 and y would be 2.